Numerous reports indicate that manufacturing has emerged as the favorite target of ransomware groups and hackers. In response, a new report from Industrial Media discusses the evolution of industrial cybersecurity, its current state, and the tactics hackers are using, including phishing schemes, malware, and ransomware attacks. It also details solutions and arming manufacturers with the knowledge and resources needed to win more fights on this highly complex and ultra-competitive battlefield. Download the industrial sector's new battlefield by going to manufacturing.net/cyber. Hi, I'm Jeff Ranke, Editorial Director of Manufacturing.net and Manufacturing Business Technology. Welcome to Security Breach. First published in 2014, the National Institute of Standards and Technology, or NIST, recently announced updates to its Cybersecurity Framework. The goal of version 2.0 of the CSF is to better integrate areas like supply chain risk management and governance. More specifically, this means a broader focus to better reflect all the organizations that use the framework's guidance, more emphasis on governance within organizations and supply chain management, better integration of resources, including the privacy framework and this national initiative for improving cybersecurity in supply chains, and finally, bringing more attention to cybersecurity measurement and assessment. All of these measures would appear tailored towards greater inclusion of the industrial sector and many of its unique challenges. And quite honestly, the timing couldn't be better. According to Proofpoint's 2023 Voice of the CISO report, 76% of industrial sector chief information security officers feel their organization is at risk for a cyber attack within the next 12 months. Our guest for today's episode will offer an in-depth appreciation for how these framework upgrades will help and what could happen if they're ignored. But before we talk to him, we're excited to announce that Security Breach is being sponsored by Pentera. For more information on their cybersecurity solutions, you can go to pentera.io. It's now my pleasure to welcome Ethan Schmertzler, CEO of Dispel, to Security Breach. Dispel is a leading provider of secure access solutions for industrial control systems. Ethan, thanks so much for joining us today, and welcome to Security Breach. So NIST has come out with a new CSF, a new framework for cybersecurity, and it's promising. It looks like it really does address a lot of things within the industrial sector that maybe there hasn't been guidance for previously. But I'd really like to get your thoughts in terms of, is this a great step? It talks a lot about supply chain. We're not talking about operational technology, but it seems like a great first step. What were your thoughts with sort of 2.0 version of the CSF that came out?
I think one of the things that was lacking in the previous version was that it assumed that there were best practices that people would be adopting. What the new revisions in 2.0 are really doing is codifying what might have been otherwise norms. So instead of saying, for example, that senior leadership should be aware of what's going on, right? Now it says that they need to be trained, informed, understand, right? They need to exactly get what's going on. It's just much more explicit about really what's being required. And so what I like about that is that it's removing some of the looser ambiguity around, again, what might have been a norm in the industry, but not actually quite crystallized. And now they've done that, which I really appreciate.
Yeah. So, I mean, it is a framework. It's not legislative action. It's not a law or anything like that. Do you think that's where we're trending a little bit? I mean, we have some things in place that already deal with what they call critical infrastructure. Is that going to come more into the industrial sector? Because the argument can be made that manufacturing is as critical as energy and water and everything else.
So I think the industry is certainly trending in that direction. I doubt that the United States is going to give NIST, for example, enforcement powers for saying you have to comply with the CSF. And the CSF is, like you say, it's not a prescriptive document. It's not specific enough. It doesn't, for example, have the length and depth of security control criteria that you might see in an ISO 27001 or a SOC 2 audit. Where I do think you're seeing this move is, if it's not legislative saying you have to do this, I do think that you're seeing insurance companies increasingly putting pressure on manufacturing critical infrastructure, saying, if you want coverage from us, specifically in manufacturing, if you want coverage by us for an incident, then we need to see that you're following the following standards. Or, to put it another way, it's a great excuse for an insurance company to turn around after an incident, point to a company and say, well, you weren't following industry standards. You guys must have been negligent. I guess I don't have to pay you. And I think that companies are going to look at that and say, we can't accept that kind of risk. We're going to have to meet these standards.
No, that makes a lot of sense. We've been hearing a lot about the role of insurance companies. It's almost been sort of a default strategy, I think, for a lot of smaller enterprises to say, if we get hit, hey, we are covered, and maybe we'll just go that route as opposed to really plugging a lot of these gaps that we know we need to. In your role, how do you address that? I'm sure you've worked with some clients who have kind of taken that approach a little bit in terms of, hey, we've got the insurance, we're covered, we don't have the money to invest potentially in a lot of really shoring up the enterprise.
Mm-hmm. It's not even small businesses as well. It's large enterprises also have historically decided to offset risk through those avenues as opposed to making the investments. I think what's changed in the last 5 years has been that the quality and capabilities of the technologies that are available, certainly for the manufacturing market, industrial market, have really caught up. And so now, whereas before people might have said, listen, I would have to have home rolled this platform, and there's really not a good risk solution or risk mitigation strategy that we have out there. There are now, I'd say 5 or 6 companies that are serving the operational technology market that have basically taken what the different frameworks say you're supposed to be doing, put them into an automated platform, and now can be deployed at scale for manufacturers in a much more cost-effective way than the old home rolled systems too.
Yeah. The one thing that is a little concerning to me, maybe you can set me straight on this one, is whenever I look at the industrial sector, there's a lot of talk about supply chain. I understand why. I get how vital it is to make sure all that's secure, but that's only half the story. We're also not looking at plant floor cybersecurity in terms of the operational technologies that are involved and are still so vulnerable. So when we look at this new framework, yeah, there's positive, but should we be worried that if we're looking at this framework and developing a defense plan off of it, there's still a lot of gaps here that enterprises need to plug in for themselves, right?
Yeah, it's one of the limitations, I think, or it's one of the problems I see with the revision in it, which is that it sort of assumes that the company that is reading the CSF is the one that is, I'd say, in the ivory tower and understands everything. So, for example, there's a clause in it that says that all of your suppliers have to meet the same standards that you do. It doesn't specify what those standards are. Now, the problem with that is, let's say that one of your suppliers works with AWS. You're not going to get Amazon Web Services to change how they do their policies. Maybe if you're the federal government, you can. But that sort of stipulation is, I think, fanciful. It also leads to conflicts or at least the potential to conflict, because there are some really big institutions that could be totally arbitrary and capricious with whatever their standards are, and they may not have any grounding, for example, in reality. So, for example, let's say that someone insists that their multi-factor authentication should be done using text messaging. Text messaging is not recommended by NIST. NIST 863B specifically states that that's a bad idea because text messages aren't secure. So just because someone has this standard and tries to push this downstream doesn't mean that that's the best practice. And so when we think about supply chain in that context and the focus on that, I think one of the challenges that we're seeing is that supply chain sort of says, oh, it's that we here are doing fine. It's someone else that's going to be at fault, as opposed to looking on our own factory floors and saying, we need to have control over this as well. And I think that's something that manufacturing and critical infrastructure still needs to really take a good hard look at and understand that that's something that they have to clean up their own house first.
Yeah. And kind of setting the tone a little bit, maybe you can talk to us a little bit about Dispel, what you guys are doing to help, the role that you play in industrial cybersecurity, I guess.
Sure. So we fit in I'd say the middle of the process. So what Dispel provides is known as zero trust access for industrial control systems. So what that means is once you've defined and you know what are all the assets inside of your factories, you then hand that information to us. And what we do is we block all access to every endpoint inside the factory or inside the plant. And then we control how an operator or a third-party vendor gets access to each different component. And then we're protecting how that session is handled. So one, we're making sure that that session is compliant with different cybersecurity standards. But then also we're destroying that network afterwards. So the components themselves are going away. So that way we are eliminating pathways that, for example, an advanced persistent threat might be looking at using in order to get access to these systems, which is something that NIST is pushing for in a lot of their federal contracting guidelines. That's where we sit, is in the center. So we're the control, access, compliance, and audit component of it. And so we're really giving that visibility into those sessions. And then where we'll hand that data off then is to the security operations center. So that's downstream from us will be what's the team that's then going to monitor and watch all those sessions. That's the folks that we hand it off to.
Yeah. What's a critical position in the cybersecurity chain, so to speak, and being at that component level? So I'd love to get your thoughts a little bit on things. When we talk to a lot of these component providers, the suppliers, the developers of them, they talk about, well, we're secure by design. So when it's integrated, all the security protocols should already be there. Basically, the plant operator, those on the floor, they just need to turn them on. They just need to make sure they're in place. I'm sure you're seeing plenty of instances where it's maybe not that simple. I'd love to get your feedback in terms of how integrating some of these new supposedly secure by design devices are impacting plant floor security.
Mm-hmm. When you think about security and secure by design, I like to talk about security as sort of as sewing a quilt. And each different control criteria that you get, or each technology you're addressing, gives you a square that you're putting into that quilt. And secure by design of a component is terrific. That may mean, though, that you're only filling one or two of the patches in that quilt, and you have to look at a holistic perspective. So I'll give you an example of that. If you, for example, have a secure boot on a chip that gets put into a factory floor, that's terrific. What that means is that we can know with some level of security that the firmware on that chip doesn't get tampered with. That's terrific. That fills one of those quilts. If we then look, though, at the four corners of, for example, something like IEC 62443, which is a cybersecurity standard that governs security around critical infrastructure and industrial control systems, that might just be one of several hundred different control criteria that we then need to be addressing. So secure by design is terrific. The question is, what's the final quilt look like, and how many other pieces do you have to fill in order to have a complete blanket?
So where typically are you stepping in to do the most work, I guess? Where is the typical gap there, and where are the holes in the blanket, I guess?
Yeah, it's about how do you get visibility into the network. So each individual component in the factory, I need to know where they all are. I need to make sure that the only way someone can get access to those devices is a way that I am approving and that I know about in a session. So for example, if someone deploys a piece of hardware, they might say, we have an SLA agreement that says we'll be able to support this device in this amount of time. But does that mean that then that company can now access that device anytime they want? Maybe. And then the question is, well, could they access anything else on that network at the same time? How do we control when they're allowed inside of my network? I need to be able to monitor that. I need to be able to inject someone. I need to know exactly which person, not just which organization, was touching that machine from the company that's providing it. So a lot of the gap that we're seeing is around that complete life cycle, the visibility, the monitoring, the control criteria around the actual access itself. And then finally, how do you clean up afterwards to make sure that you've gotten rid of any access portals that were maybe available? Want to make sure we get rid of those so that the only sessions that should be there are the ones that we know and gave permission for, so that way our security teams that are monitoring what's going inside of the factory can say, we know that any traffic that's in here should be blessed. Therefore, any traffic we see that we don't expect to see must be something that we should be investigating.
Okay. I want to dive into that a little bit there. And I'm going to say maybe the point that you referenced, give you my thoughts, and you tell me if I'm right or wrong. I would say from when it comes to monitoring a lot of these systems, I think we're pretty good. I think the industrial sector does a pretty good job. Maybe we need to be more sensitive to some of the discrepancies that we see in terms of people just probing to see what happens, basically, if temperature spikes by a little bit or pressure spikes by a little bit, what the response is. But overall, I think we're doing okay monitoring. Would you agree?
Yeah, and I think that the reason why we're really good at monitoring is because it's a technology that we really perfected in the IT world and actually forklifts pretty darn well into the OT world.
Yeah. Visibility, I think we're doing terrible. I think some enterprises are pretty good, but I think if we put the whole industrial sector together, I think visibility is still a huge concern. I don't think that we really know about all of our connection points. I don't think we really know how all of our technologies are working together. What would be your thought?
I agree completely. So it's really bad for a couple of reasons. One, when we talk about new fancy hardware that you can buy for a factory 4.0, all the new stuff, that's great, terrific. Yeah. Most equipment is 20 years old and it is not going to get upgraded. It is going to wither on the vine, and that's going to be its strategy there. So one, this stuff, if you try to use IT tools that were good IT network mapping tools, a lot of them can actually have unintended consequences in an OT environment. They can cause restarts, for example, which you do not want to have a sudden component start restarting on a factory line when it's actually operating. That'd be a security risk, or a safety risk for the people in there. So a lot of the IT tools that exist for network visibility do not work well in OT environments. So that's step one. Step two, a lot of the times the factories that exist now were purchased or bought or rolled up by the parent company that now owns them. So when they bought that company, that subsidiary, they don't know what's inside of those factories. So if you have 50, 60 factories globally around the world, you're not going to necessarily know exactly every single endpoint that's inside of all these environments. And you don't know what people have plugged in. It's it's almost as bad essentially as hospitals, which are incredibly porous network environments.
Yeah, no, I'm glad you brought that up. I think that's an excellent point. Something we've talked about before here on the show as well. So when we're looking at these vulnerabilities, and we're there because visibility is still an issue, are there any particular types of attacks you're seeing, or certain groups or tactics that have been proven more effective lately, or are kind of on your radar more right now?
Mm-hmm. I think they fall on two ends. It's a barbell sort of situation. For companies that are putting in better and better security. In other words, if they just sit down and follow what NIST standards are saying they should be doing, not just the CSF, but also 853, 882, there are very specific frameworks that talk about protecting critical infrastructure and manufacturing and how to build cyber resiliency. If you sit down and actually follow all those, you're going to deal with, I think, most of the problems that you're going to confront. The step that you're then dealing with is the people you might be vulnerable to are advanced persistent threats. Whereas other companies have historically said, if an APT is going to target us, we're going to lose. I guess we'll just throw up our hands and then that's it. If you're a critical infrastructure provider, whether you like it or not, you don't have a choice. You have to deal with that. So the way that people are starting to confront that are the kind of technology they can deploy to deal with those specific problems. Technologies like moving target defense, which is designed to make the cost of finding one of these networks enormously high for a state level actor. That's one side. On the other side, the kinds of attacks we're seeing are the relatively cheap ones that you can do at scale. And that is specifically going after humans. So ransomware attacks, phishing attacks, areas where people are trying to send information, get people to become accidentally complicit in a compromise is a heck of a lot cheaper than going after the actual infrastructure itself. Because they're usually segmented to some extent, sometimes they're not, but really going after the human side of things is a cheap and a straightforward way of attacking critical infrastructure, and surprisingly effective a lot of the times if the organization hasn't taken appropriate steps.
Well, next question, obviously. I know there's no silver bullet, but the human factor is such a big part of cybersecurity. Do you have any thoughts on terms of successful training initiatives or ways for people to really understand the significant role that they play in the defense of their entire enterprise?
Mm-hmm. Creating a culture of security is incredibly important. I think, though, at the end of the day, you have to take humans out of the loop. So you need to make it so that a human being, if they make a mistake, still can't give someone access to one of these environments or allow their computer to become a pivot point. So we just assume that any information we give to a person is therefore compromised. Any hardware device that we connect to, we assume is compromised. And if we just start with that presumption, then we don't have to hope that we've trained everyone properly, or that they don't make a mistake, or that they're just not sleeping, or they just don't care. All that stuff sort of goes away, because assuming that humans are going to do all the training, that we're always going to be right, I think that's a big mistake. Machines are really good at being good all the time. Humans are really bad at that.
Yeah. So, well, I mean, this is a natural segue into the next topic, which I'm sure you're getting bombarded with right now. I mean, are you talking about implementing more artificial intelligence into sort of the cyber defense landscape?
Artificial intelligence is part of it, certainly on the monitoring side of things, on the coaching side of things, but it's also about thinking about the kind of intelligence, information, and data that you're giving to folks. What we are seeing, AI certainly, just to speak about that, what we're seeing AI being used for is it drops the cost of making an effective cyber attack pretty significantly. In other words, the kind of emails that you might, for instance, get nowadays that are generated by an AI sound a lot more genuine. And so they're really good at building maybe that trust and rapport, as opposed to the old, let's say, humanly crafted ones, which weren't great, frankly. I mean, we get phishing attacks all the time. They're not very good. And AI can now just increase the volume of well-crafted attacks against folks. And as you see this right now, we're seeing that in text, but we're probably going to see that more in voice and stuff like that. Where this takes us is to another question, which is the kind of trusted communication channels that people are allowing folks to use. Emails and phones are inherently what are called promiscuous devices or promiscuous channels. They allow anyone to send them a message. And so people kind of just trust that those messages might be legitimate, as opposed to saying that actually the only way that people should be communicating with someone else over any kind of sensitive information or anything of any kind should be an environment where I know exactly who that person is and I can vet them and I can put them into a lockdown environment, as opposed to trusting a phone or an email.
No, great point. I'm glad you put it that way. Never heard him described as promiscuous before, but that's dead on. That makes a lot of sense. We've been talking about the human factor here, and part of that is also the fact that we really have a shortage of cyber expertise within the industrial sector and specifically within the OT realm. Wonder if you have some thoughts there on maybe what organizations can do to either try to develop that talent internally or find it externally.
Mm-hmm. It's a huge problem. So I'll give a case example that we see all the time. So there are basically 8 different buckets of technology you need in order to implement a NIST aligned remote access platform. It's no longer just a VPN. I've got to have it tied into identity access management. I've got to do all these different things. If you want to deploy that yourself, in other words, if I want to just go out myself as the organization and build one of these platforms, it'll take you about 6 to 8 FTEs, full-time employees, to do that. Plus, you're going to have to go in and buy those 8 different technology platforms. If the average cost of a security person is about $90,000, let's say, and that's maybe conservative here in the United States, you're looking at between $500,000 to $750,000, fully wrapped, a full $1 million on full-time employees if you can get them. Yeah. That's really expensive. Most security organizations aren't going to spend that kind of budget on just implementing secure access, let alone everything else. So I think you're seeing much more, or many more organizations push things into managed services. So automation, or in other words, making the staffing someone else's problem. And what you're really getting to there is economies of scale. So relying on another organization to hire those 6 to 8 FTEs and then have them be dedicated across multiple different organizations. So that's the step one is SaaS products, managed services. In terms of talent and training, I think it's not just making it the responsibility of IT personnel or cybersecurity teams to be focused on this. And I think you can see this consensus in the new revision of NIST CSF in 2.0. And what they're saying in that document is it's no longer just the responsibility of the security team. It's also now this responsibility of senior or organizational leadership, and it's responsibility of the people that allow things into the organization. And they mean specifically about that is procurement for IT services and anything that you're buying, but then also human resources. The people you're bringing in and you're training them, you are now, as a department, responsible as well for cybersecurity because you're making the calls on who's actually you're allowing into the organization and how you're training them. So it's not just expanding the size of the IT team, it's pushing responsibility out to everyone else that they now own part of this problem.
No, it makes a lot of sense. Definitely share the load a little bit. And the fact that there is some framework around it, hopefully will push more people to put greater emphasis on it internally as well. Kind of wrapping things up here a little bit, Ethan, this has been fantastic. But just looking ahead the next 12 to 18 months or so, what do you think some of the bigger trends for cybersecurity in the industrial sector are going to be?
I think that what we're seeing right now is a rapid consolidation of the technologies that are available. And what I mean by that is When I characterize what Dispel does, I said that we sit in the center of this. So someone else does the asset inventory, they hand that to us, we then control those assets, and then we hand the security monitoring off to a SOC or a SIEM. And so it's sort of that 3-step process. And the reason why is because each one of those categories is actually an enormously expensive, complicated thing to build. What you're seeing now is companies in the market have clearly said, great, but they're always going to buy all 3 technologies. So shouldn't these be tightly integrated with one another? And so what you're seeing is the kinds of partnerships that are coming out between the companies that provide these managed services are increasing. The other thing you're going to see in the next 12 to 18 months are the manufacturers of the hardware themselves starting to leverage the name brands in the security sector as a way of giving themselves both recurring revenue, but then also sort of standardizing who's delivering these capabilities across the board.
Thanks, Ethan. And for more information on the work Dispel does, you can check them out at Dispel, Dispel.com. Thanks for joining us today. And to catch up on past episodes, you can go to manufacturing.net, IEN.com, or mbtmag.com. You can also check Security Breach out wherever you get your podcasts, including Apple, Amazon, and Overcast. And if you have a cybersecurity story or topic that you'd like to have us explore in Security Breach, you can reach me at jeff@ien.com. For Ethan Schmertzler, I'm Jeff Ranke, and this is Security Breach.